All right, let's learn about the octet rule and how to draw Lewis structures. So first, the octet rule is just like it sounds. It's all about the number 8. Atoms want to form bonds by sharing their valence electrons, for covalent bonds that is, until they have 8 valence electrons around each atom. There is an exception though. Hydrogen is just a small atom, and those near it. So it's actually happy with just 2 valence electrons. And we'll look at some examples too. Okay, so now that we know the octet rule, let's say that you're asked to draw the Lewis structure for NH3. How do you do it? Okay, and what I mean by Lewis structure is a structure that shows any shared electrons as a line. Okay, so your steps are going to be first, put atoms that are at the start of the formula in the middle. So in this case, N is at the start, so N is going to go in the middle. And it says, then you're going to draw the Lewis dot diagram for each of the atoms and determine how many bonds the element can form. So let's do it for nitrogen next. Nitrogen is right here. It's in group 5A. That means that it gets 5 valence electrons as dots. Okay, so we start on any side really, but we're going to draw 5 dots. 1, 2, 3, 4, 5. And remember, electrons like to spread out before they pair up. So the number of lonely electrons is how many bonds this will form. So this has got 1, 2, 3 lonely electrons. I'm going to erase those though. And then let's draw our hydrogens. So hydrogens have 1 valence electron because hydrogen right over here is in group 1A. So then we connect the lonely electrons together to show the formation of a covalent bond. Here we go. We've got 3 hydrogens and there were 3 lonely electrons. Now let's make sure everyone's happy. Okay, so each should have 8 or 2 to be happy. So let's start with nitrogen. It's got 2, 3, 4, 5, 6, 7, 8 that it's sharing. And each hydrogen has 1, 2, 1, 2, 1, 2. So this does follow the octet rule. Now, I'm going to redraw this, just showing lines and the lone pair. Okay, so just lines instead of showing all the dots. It's nice to have those. I'm okay with you leaving it, but this is kind of a little bit cleaner and how you would see the structure drawn in an actual, science journal, for example. Okay, so we solved the puzzle. I never read number 3, but number 3 says, start bonding atoms together like a puzzle and make sure you follow the octet rule. You'll know you're done when there are no more lonely electrons. All the electrons need to be paired. Then it says, in your drawing above, please label lone pairs versus shared electrons. Okay, so right here, this is called a lone pair. So this molecule has 1 lone pair. These here are shared electrons. Each of these is a bond representing 2 electrons. They're shared electrons. All right, let's do some more practice. Draw the Lewis structure for H2O. O is number 8. So here's O, it's in group 6A. So that means that it gets 6 valence electrons. 1, 2, 3, 4, 5, 6. So it's got 2 lonely electrons, and there are 2 hydrogen atoms just waiting to bond. 1, 2. There we go. And it didn't ask, but here are the lone pairs. And the shared electrons are in these two bonds here. 1, 2. And then I want to redraw this nice and neat since that's kind of been my thing. Here we go. We've got our H2O. Now you might say, oh, I'm just going to ignore the lone pairs. That's bad. Don't do that. Okay, because we are going to realize how important these are when we start talking about why molecules are in the shape that they're in. Okay, so don't leave those out. Next, it says draw C3H8. I'm going to remember my tip that said draw the first atoms in the center. So I'm going to draw 3 carbon atoms. Carbon's in group 4A, so it gets 4 valence electrons. You know what I should do is just make this easy on myself and do like a really thick there. That's so much better, although now my lines are going to be crazy. Okay, so I'm going to start by connecting each of these together. And then I've got some hydrogen atoms that I need to put somewhere. In fact, I've got 8 of them. So I'm going to draw them all ready to connect to the 8 remaining lonely electrons on the carbon. So connect, 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 connect. Every carbon has 8 electrons, or it feels like it has 8 because it's sharing, and each hydrogen has 2. So we are not in violation of honk 1, 2, 3, 4, not in violation of the octet rule. And then to draw this nice and neat, we would just draw lines instead of, the dots first. So then you can just see it nice and clean. All right, CO2, hint. This one has some double bonds. So let's see, we've got 1 carbon and 2 oxygens. And oxygen is in group 6A. So it gets 6 valence electrons. And since it doesn't matter which direction the single ones point, I'm going to point them toward the carbon because I know that I'm going to be bonding these with the carbon. Okay, so we can start connecting each carbon to an oxygen. And then I can see there are still lonely electrons that need to connect. And so this one definitely could benefit from being drawn nice and neat. There's double bonds around the carbon. And then don't forget the lone pairs. They like to be opposite of each other because they repel. And so that would be the nice way to draw this. And again, if we're looking at the octet rule, carbon has the 4 original and then it's sharing another 4. So the carbon is happy and has 8. And the oxygens have 1, 2, 3, 4, 5, 6, 7, 8 that each of them is sharing in total or has in a lone pair. All right, next, draw the structure for HCN. C always goes in the middle, is a good rule. Let's draw the N over here, and then we'll go from there. So where's my big, here we go. 1, 2, 3, 4. I'm going to keep my pair together so that I can face the lonely electrons toward carbon. Carbon is in group 4A, that's why I drew 4 dots. Nitrogen is in group 5A, that's why I drew 5 dots. So I want to connect everything at least once, and I haven't drawn my hydrogen, so I definitely want to get that in. Okay, and then I can see that there's still lonely electrons here. So that's going to form a triple bond. And then if I'm going to draw this nice and neat, that carbon triple bonds to the nitrogen. The octet rule is in place. We can double check. Carbon's got 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is just a little guy, so it's happy with 2. And nitrogen also wants 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, next one. Draw the structure for CH3PCl2. So I'm just going to draw the C and the P first. So carbon's in group 4A. Phosphorus is in group 5A. And I want to connect them together once. Now, it says there's 3 hydrogens, so kind of a nice option would be to draw the 3 hydrogens, each connecting to those 3 lonely electrons on the carbon. So 1, 2, 3. And then it says there's 2 Cls. Now, Cl is in group 7A, so that means it has 7 valence electrons, and only 1 is lonely. 1, 2, 3, 4, 5, 6, 7. So connect and connect. Everybody's connected. We can draw this nice and neat, although this isn't terrible. And the most tedious thing about redrawing is you definitely still need to draw all the lone pairs. Because again, those will come into play when we talk about shape. So there we go. All right, we've got one more to do. I would definitely pause the video and see if you can draw C2F2 on your own. And then start the video and see if you did it. This will be your test. Okay, so pause. All right, we're back. I'm going to put my C's in the middle. It's good to make things symmetrical. And I'm going to put my 2 fluorines on the outside. Carbon gets 4 valence electrons, and fluorine gets 7 valence electrons. And then let's start connecting things. You want to connect everything at least once first. And then you can see there's still 2 sad and lonely electrons on the top of the carbon atoms and on the bottom. So those need to be connected. So there should be a triple bond between the 2 carbons, single bonds to the fluorines, and each fluorine has 3 lone pairs. The best way to get good at Lewis structures is to keep practicing, making mistakes, and learning from your mistakes.